Now we're going to take a look at what if we are going to take the product or the quotient of a complex polar number. So remember, if I have something like 5 CIS, say 12 degrees, that means the same thing as 5 parentheses cosine 12 plus I sine 12. I'm using degrees just for convenience, but the same thing applies in radians. So if our first point is 3 CIS 10 and our second point is 4 CIS 40, we want to find the product. So we're actually going to go ahead and prove a theorem that will help us to do this a bit more quickly than it's going to take me right here. So I want to find this product, so I know that I'm going to do 3 CIS 10 times 4 CIS 40. And right away I'm going to see that I can do 4 times 3, and I will get 12. So 12. But I'm not going to be able to directly multiply this cosine I sine. So we're going to have to do a bunch of work right here. So we're going to say 3 cosine 10 plus 3 sine I sine 10 times 4. Oh, I already did the 3 and 4, didn't I? I don't need the 3. Times cosine 40 plus I sine 40. I don't need the 3 and 4 because I already did that. The 3 times 4 is 12. So I have my 12. All right, now I'm going to multiply this out. And that would be this times this, and that's going to give me cosine 10, cosine 40. And then cosine 10 and I sine 40. So I'll write it like this. And then this times each of those. So plus I cosine 40 and sine 10. You could write it in a different order, but that's fine. And the last one, now I'm going to get I times I, which is I squared, so that's going to be minus. So we're going to remember that I squared equals -1. So I'll have a minus here instead of a plus, and sine 10 and sine 40. So at this point, we do have this long list of things right here, and we want to take a look at, well, what about these two trig identities, these sum and differences, because that's what this is looking like. I have a cosine 10 and a cosine 40, and I have a minus sine 10 and a minus sine 40, so I'll just go ahead and collect those together, and that's going to look like this identity right here. So let's collect those together and see what's left, see if maybe something else pops out at us. All right, so that's that part, and then I have plus. Now I do have an I hanging out here, but I see I'm really close to basically this identity right here, the sum formula for sine. So if I factored out the I would have this quantity of cosine 10 and sine 40 plus cosine 40 and sine 10. So that gives us 12. This is our sum formula for cosine. So I could write that as, well, if I add those two angles, that gives me 50. So that will give me cosine of 50. All right, so that's that part plus, so I have a plus here, I, and this is the sum formula for sine, and 10 plus 40 is still 50. And this is our CIS format, so 12 CIS 50. All right, so now if we take a look back at the beginning, what we had, we do see that the 12 comes from 3 times 4, and our 50 comes from simply adding our angle. So we can say for any two complex polar numbers, Z1, if it's in the form A CIS, I'll call it theta 1, and Z2, if I have B CIS, that's an I, theta 2, my answer is going to be the product, so the product of those two is going to equal AB CIS theta 1 plus theta 2. So let's take a look at how we might do this for two other examples. So I have two complex numbers there, and again, complex polar, and again, if we had cosine plus I sine, it's the same thing. This is actually pretty easy. 24 CIS, and I'm just going to add those two angles right there and get 93 degrees. And again, you can do this in radians, same thing. And right here, we'll get negative 24 CIS, looks like 49 degrees. Now, often when we've done like log properties and exponential properties, we saw that whenever there's a product rule, there's an opposite quotient rule. So we saw like with exponents, if you had like x squared times, well, x to the 6, we would add those things we saw and get 8. And if I was dividing them instead, we saw that we subtracted them. And we'll see actually, and I'm not going to go through a proof, but like I did at the beginning, but basically a similar thing happens here. So instead of multiplying these, I'm dividing them. So for any two complex numbers, if we have the form A CIS and theta 1, and if our angle 2, or our second number is B CIS theta 2, then if I want to divide those, my answer is going to be A divided by B CIS, subtract our angles. So in this case, I'm going to get, well, 18 divided 2 is 9, CIS. I subtract those two, 25 minus 5 is 20, and done. And right here, if I wanted to divide that, 20 divided 4 is 5, and then CIS, subtract those angles and get 7 degrees. Not too bad at all.